Welcome to a deep dive into the world of machine learning. It's more than just a buzzword. It's behind so much tech we use every single day.
It really is, and it's only growing. I mean, think about translating languages on your phone. That's ML.
Right. But it's not just convenience. This stuff's tackling huge problems, too. Self-driving cars, disease prediction things we used to think were sci-fi. So are we ready to break it down?
Absolutely. Let's start with the basics. What is machine learning? It's about teaching software, we call it a model, to learn from data, but not like regular programming. We don't give it step-by-step instructions.
So instead of coding every single rule, we're letting the model figure out the patterns by itself.
Exactly. Imagine trying to predict, let's say, how much a house will sell for.
Okay, yeah.
But the old way. We'd have to code in every factor: location, size, condition of the house, the market. It'd be a nightmare.
Impossible to get perfectly right, probably.
Right. With ML, it's different. You give the model TONS of data, past house sales, prices, all the details. And it analyzes it, finds relationships between those details and the final price.
Like connecting the dots, finding the hidden links between all that data.
Perfect analogy. And once it's learned those links, it can predict the price of a new house it's never even seen before.
So in a way, it learns from experience, just like us.
Exactly. That's what's so cool about it. Now, there are different types of these ML systems. Today, we're focusing on two: supervised and unsupervised learning.
Okay, so supervised learning. Is it like having a teacher involved?
You got it. Think of it like learning to identify different birds.
Okay.
Someone shows you a robin and says, this is a robin, then a sparrow, this is a sparrow. You get labeled examples.
Ah, so that's the supervision part. The model is told the right answers from the start.
Right. In supervised learning, the data has labels. The model's got to figure out the link between the data's features like the bird's color, size, beak, and its label, the bird type.
So then it can label new birds it sees, right? Red breast, probably a robin.
Exactly. And within supervised learning, there are two main tasks: regression and classification.
Regression is for predicting numbers, right?
You're catching on quick. Think back to the house price example, predicting a dollar amount. That's regression. Or tomorrow's temperature, or how long your commute will be.
Okay, so it's about getting a specific number. What about classification then?
That's about sorting things into categories, like, is this email spam or not? Will this customer buy this product? Does this medical image show a certain disease? All those are classification problems.
Got it. Regression gives a number, classification sorts things out. But how does the model actually learn during training? It can't just be magic, right?
It is kind of magical, but there's a process. We got to dig a bit deeper here.
I'm ready to go deeper. Let's do it.
All right. Imagine our house price model is just starting to train. It looks at the features like square footage, number of bedrooms, tries to predict the price.
First try, it's probably way off, huh?
Totally. But here's the key. Every prediction gets feedback. It sees the actual sale price, the right answer, and compares it to its own guess. That difference, the error, is what drives the learning.
So it's like it's constantly checking its work and adjusting based on how far off it was.
Yes, it uses this math thing called gradient descent to tweak its internal parameters. Think of those parameters as the knobs and dials that control how it makes predictions.
Ah, okay. So if it guessed a house price way too high, it would adjust those knobs to bring the prediction down next time.
Precisely. And this cycle, predict, compare, adjust, happens over and over for every example in the data.
So the more data it sees, the better its predictions get.
You got it. It's constantly fine-tuning its understanding of the relationship between those features and the target, like the house price. And get this. Data scientists, the folks designing the models, they can influence this by tweaking settings and choosing which features are included.
So it's not just about feeding it data. There's an art to choosing the right data and fine-tuning the process.
Yeah, totally. And that's one of the things that makes machine learning so dynamic, always evolving.
Okay, I think I'm getting how this supervised learning works. But we talked about another type.
Yeah.
Unsupervised learning. What's the difference there?
With unsupervised learning, the model gets data, but no labels. Like a jigsaw puzzle with no picture on the box.
Whoa, okay. So no right answers, no teacher telling it what's what. It has to figure it out itself.
Exactly. It does this by finding patterns, hidden structure in the data. One common task is clustering.
Clustering, so like grouping similar things together.
Yep. Imagine customer data, their buying habits. An unsupervised model could analyze that and find groups of similar customers. Maybe one group always buys electronics, another loves organic food,
So businesses could use that to target their marketing better or even make new products for specific groups.
Exactly. And the cool part is it can find patterns we might not even know were there. like shining a light on hidden connections.
So supervised learns from labeled data. Unsupervised finds its own patterns. Any of the big categories?
There are, but let's do one more. It's super hot right now. Generative AI. That's what's behind those AI image generators everyone's talking about.
Oh, yeah, the ones where you type in something crazy like a cat riding a unicorn through a rainbow, and it makes a picture of it.
That's it. These models are trained on huge amounts of data, images, text, music, code, and they learn to create new content that follows the same patterns.
Like it's absorbing the style of all that data and then using it to make something original.
Exactly. It's like having a computer that can paint like Van Gogh or compose like Mozart.
Mind-blowing, honestly.
Yeah.
What are some examples of what this generative AI can be used for?
Well, besides making fun images, it can write different kinds of creative content like poems, code, scripts, even music. And it's being used for drug discovery to come up with new molecules for medicines.
Wow, so it's not just for art and fun, it's doing some seriously important stuff too. What's crazy to me is that it can seem so creative, like it's got some artificial imagination.
Yeah, it's pushing the limits of what we thought computers could do. Makes you wonder about the nature of creativity itself. Is it truly creative or just really good at copying the creativity it learned from?
Now that's a deep question. Maybe one for another deep dive, But for now, can you break down how these generative models actually work?
At their heart, they use something called a neural network. Think of it like a simplified mathematical model of the human brain.
So neural networks are the engine behind generative AI.
Yep. You've got layers of interconnected nodes, kind of like neurons that process information. During training, the network is fed tons of data, and it adjusts the connections between those nodes, learning to recognize patterns in the data. Say you're training it to create cat pictures. It'll learn what makes a cat, the ears, the whiskers, you know.
And then it can create new, unique cat pictures from that knowledge.
Exactly. You give it a starting point, like a random noise pattern, and it transforms that into something that fits those patterns it learned, like giving it a blank canvas and saying, paint a cat.
This is wild.
Yeah.
Feels like we're only just starting to see what generative AI can do. What's next? Where do you see it going?
Oh, we're just at the beginning. One exciting area is multimodal models. Models that can work with more than one type of data.
Multimodal. So instead of just images or just text, these models can understand and generate stuff that combines both.
Exactly. Imagine a model that takes a text description and creates a video from it, or one that looks at a picture and writes a perfect caption for it, bridging the gap between different ways we communicate.
That's incredible. It seems like these multimodal models could change everything, from entertainment to education to even scientific research. The possibilities are limitless.
They really are. I think we'll see some mind-blowing stuff in the next few years as these models keep getting better.
Before we get lost in the future, let's get back to reality for a second. What are some real-world uses of generative AI we're seeing today?
One big area is image enhancement. You know those photos where the background is a mess?
Ugh, yeah. Trying to get a good picture of your dog, but there's laundry all over the floor behind them.
Yeah. Right. Generative AI can remove or replace those backgrounds, make the photo look professional, or upscale a low-res image, make it sharper.
Super useful for businesses that need great images for their websites or marketing. Saves them time and money.
For sure. Another cool application is personalized learning. Imagine an AI tutor that adapts to each student's needs.
That would change education completely. No more one-size-fits-all teaching.
Exactly. It can create a unique learning experience for each student based on their style and pace, or generate practice problems that target their weak spots.
Sounds like generative AI could make learning more engaging and effective for everyone. And we haven't even talked about healthcare, right?
Good point. It's already helping doctors diagnose diseases earlier and more accurately, and being used to develop new drugs and treatments.
It's pretty amazing to think about how this tech is already improving lives in so many ways. Things are changing so fast, tech-wise, it's hard to keep up sometimes. How do you think these developments in machine learning, especially generative AI, are going to affect us going forward?
It's the question, right? I mean, these technologies, they're powerful. They really could change so much about how we live and work.
From what we've talked about, it seems like there's so much potential for good personalized learning, medical breakthroughs, all that. But are there any, downsides, risks we should be thinking about?
Of course, any powerful tool, there's always another side. One thing people worry about is jobs, you know?
Yeah.
As AI gets better, it could start doing tasks that humans do now. Some jobs might be lost.
It's a real concern. I've even seen articles about AI writing news stories or composing music. Do you think creative jobs are at risk?
It's possible AI could automate some parts of those jobs, yeah, but I don't think it can ever replace human creativity entirely.
Hmm.
AI can be amazing for generating ideas, trying new things, but it's still us humans who bring that unique perspective, the emotion, the judgment that makes art truly great.
So maybe instead of replacing artists, AI will become more like a partner, a collaborator in the creative process.
Exactly. It can help us get unstuck, explore new ideas, push the boundaries further.
That's a much more hopeful way to look at it. What about other risks, though? Like, could someone use these AI systems for bad stuff?
That's definitely something we need to be cautious about. Any technology can be used in the wrong way. It's crucial to have safeguards to prevent misuse and to build a culture of responsibility around AI development.
So it's not just the tech itself, it's how we use it, right?
Exactly. We have to think about the ethics, make sure these systems are being built and used in a way that aligns with our values.
So what can we do as individuals to help make sure AI is used for good and that everyone benefits from it?
First thing, stay informed. Learn about this stuff, what it can do, what it can't do. Get involved in the conversations about its impact.
Like what we're doing here on the deep dive, breaking it down, getting people thinking.
Exactly. The more people understand AI, the better we can navigate the changes and guide its development in the right direction. And don't be afraid to ask tough questions, challenge assumptions, demand transparency from the companies building these systems.
So knowledge is power, in a way. It gives us a voice in shaping the future of AI.
Absolutely. The future of AI isn't set in stone, it's something we're all creating together. Our choices now matter for the world of tomorrow.
Well, I'm feeling a mix of excitement and maybe a little overwhelmed by everything we've covered. This has given me a lot to think about.
I get it, it's a lot. But that's what these powerful technologies do, you know? They make us question things, show us what's possible, force us to grapple with big questions about humanity's future.
So to our listeners, thank you for joining us on this deep dive into machine learning. We hope you've come away with a better understanding of how it works, the good it can do, and the things we need to be mindful of as it keeps evolving.
And remember, this is just the start of the conversation. Stay curious, keep learning, and let's work together to shape the future of AI in a way that benefits everyone.